number 1, we have 2 steel pipe plates, actually, each, okay, and 12 mm thick. Hard to the section of the plate actually is this. Is to be joined together by a welded lap splice. Should use for the weld has a 550 MPa. So this is FU actually. So determine the maximum weld size can be. So maximum weld. So in this type of question actually, so it is through the standard, the code. So no need to solve. According to the code, you need to answer. So in the code, there are limitations of the wheel size. Then you can get how you gonna determine. So I think it's determine the effective net area of the fillet weld using the maximum weld size allowed by the code. So with respect to that one, so you need a fillet weld. So times mo sa area man. So multiply it by thickness, the thickness of the length of a weld. Okay. So weld size times the length, that would be the effect. So determine the maximum load that can be resisted using the maximum weld size allowed by the code. So you have a maximum weld size calculated already in A, and you need to determine P. You have the formula 0.707 is times length times the allowable shearing stress. Okay. Dali na kayo, class. So if you're familiar with that, this is the figure. You splice actually, this splice, if you will see the top of it, you will not notice it. But if you will get the side bit, you will see that the two steel plates are being the splice overlap, and then you have a welding on the both ends of the two steel plates. So here and here, and then your welding is all throughout the width of size used, maximum size of weld that can be used. So you will go to, so let's try to solve. And familiar about the code. So kung naana mo, maybe you have the National Structural Code of the Philippines. Okay, so for question A, you have here the maximum size of weld. So under 4.6 of our presentation slide, during our discussions, under 4.2, limitations of fillet weld. Okay, fillet weld limitations. It is number 2. It is mentioned that weld size, okay, material 6 millimeter or more in thickness, which is the thickness of our problem is 12. So more than. So it is in this criterion. Okay, the material 6 millimeter or more in thickness, not greater than the thickness of the material. So i-minus ra nimo to kung thickness niya 12 minus 1.5. You will have your answer already. That is the maximum size that you can use. So the thickness was to 10.5. So you cannot solve anything about this. It's only through the national code, the National Structural Code of the Philippines. So makita nimo dito, this is the criterion under discussion slide 4.6.2, limitations of fillet weld. Number 2, point B. And this is what it states. Okay, so you solve already the question for A. Then you proceed. Calculate the effective area with respect to the what? The size of weld. Maximum size of weld. Accepted by code. So you will use that one for question B, effective area of fillet weld under 4.6.1. So effective area of filly weld. Number 1, the effective area of filly welds shall be taken as the effective length. Ito lang effective length. So it's equals to the width. Effective length of the weld. So effective is equals to the width of the steel plates times the through. Effective length. Effective length niya, calculated na to, times the truth, times the effective through thickness. Okay, so the effective length niya is 350. Duha man to siya kay overlap. Ang usa diri nga welding, on the other end, 350 ang gitason since the width of the splice plate is 350. Plus, usa po diri nga weld on the other end. So muna siyang times 2, which is the effective length of weld is 750. Okay, so the effective through thickness, okay, this is the formula. We know this 707 times thickness. How much will the thickness as we calculated based on acceptable criteria of the code is 10.5. 12 minus 1.6. 1.4. 12 minus 1.5 actually. So you have 10.5. Calculate that one. You have the true thickness. So true thickness, class, remember. Kung saan man itong true thickness? So theoretical, katong theoretical nga line, theoretical welding line, perpendicular distance for that, going intersection between the beginning of the weld to the outer, the last point of the weld. Project that one, that is the root or the origin, what we call the root, and the distance from that perpendicular to the theoretical line, that is what we call the truth. Okay, so thickness is equals to 0.707 times the what? Thickness of the weld. So thickness of the weld is 10.5. Okay, so you will get the effective thickness. So you can solve already the effective area. So ang effective area with respect to the maximum size of weld, which is 10.5. So 4235, which is equals to 5197. Is it correct, class? Sakto. I haven't verified this one. You can calculate using your calculator 7.4235. It's not correct, right? How much? You get, class? 707.
5,567.
5567.
5567. Okay.
Yes, sir.
Times 74235 times 750 is the effective length. So 5567. So this actually 5567.625, right, class?
Yes.
Okay. 5567.625 square millimeter. Okay, that is your effective area. So, mo na yung effective area with respect acceptance of the code, of the National Structural Code on the size of the wheel. Okay. Now, let's continue for question. Okay, I will change this one because maybe I will upload the same. It will have a conflict. 5567.6625. Okay. So you have this area already. After that one is the question. For question C, we have here maximum load P. So how are you going to calculate the maximum load P? So, mo ito pag-calculate sa load P. May formula, 0.707. So, 0.707 times the length, total length of wheel. We have P is equals to the shear force to how much? Times the shear area. What will be shear area? So, pila man ang shear area? We consider this one as equal. So, ang shear area na 2.707 thickness times the width of the weld times length. Okay, so let's have shear stress. The allowable shearing stress is equals to 0.3 of FU, which is, you can go back on our discussions, that is under equation 3.4. Okay, we can calculate since FU is given on this problem. So how much is the FU? We'll go back. I forgot how much is the FU. Okay. FU is equals to, nominal tensile strength is 550. So 550, we'll substitute that value. Okay. So we have 0.3 of FU. So 0.3 of FU, 550, that would be 330. Class, don't be confused because I put also reference on some of the formulas where we get this one. Okay, 0.3 times 550, 330 MPa. Nya ang shear nimo, shear area, 0.707 thickness times length. Napo na sa equation 3.5 if I'm not mistaken. 3.3 actually ang shear area. So, times nimo, ang kaning T is the leg man na siya, wheeled leg actually, which is equal siya mo ng 10 point times nimo sa length of the wheel. Yang length of the wheel, we consider only the upper wheel. So 350 ra. 350. So kay shear man, shear. So ang take note class. Ang the direction sa force on the horizontal. So ang imuhang you will have here this formula times the leg nga 10.5, which is according to the code the total sa to hindi ko ganito ko memorize. Actually, we'll go back. So okay, the maximum size of wheel actually is equals to what? Not greater than the thickness of the material minus 1.5. Moto nato 10.5 actually. So let's move on. So we have here 0.707 times thickness times the length. So ang thickness nimo is 10.5 times, we consider the upper weld only, 350. You will get the shear stress. The shear area actually is 2,000. Can you calculate, class? Maybe basin sayop na po niya ni. Can you calculate if it is correct? 707 times.
Kanang sa kuan, sir ba? Sa FB, sir. Kay ang 0.3 times 550 is equal to 165.
Sayop din na. 5. Sana guni. Okay, 165. Okay, it's 165. That's correct. We will verify the given. The given is 550, right? Okay, it's 550. So you will get the value of 0.3 times 550 is equals to 165, and that is correct. Okay, 165. Change that one into 165. I will change. Okay. 1 minute. 165. Nasaan na to? Yung sinayop mga ganin mga 165. Okay. It's 165. Okay, 165. Okay? And then, you have, is the area correct, class? Exacto ang area? Class? Is the area correct? Calculations. 0.3.
Yes, sir.
Okay.
Sakto
So,
na, sir.
it's correct. Let's go back on this. Okay, so let's continue. 165 megapascal. So 0.707 times thickness is, you will get 0.07707 times 10.5 times length is 350. So don't be confused about the length of the weld. This is the thickness of the steel plate, because ang imong weld is from the top to the bottom. Okay, so the maximum load, so it's substitute the calculated values. FB, kanimo na sepo gani. FB is equals to 165 times, okay, 165 times 2598. That would be, okay, we'll change this one. How much, class? Kailan value, class? 165 times 258. 2598. You will get a value of 428,670, right?
Yes, sir.
Okay.
Sir.
428. Okay, 428.67. Okay. So you will get a value of 28, okay, 0.67. So that is your maximum load. Class, kung pag-solve ko ninyo, consider ninyo nga ang total nga gi-weld ninyo only lang 350, what will happen? Ang imong length, kani kay considering the upper weld only, what will happen? Ang imong length will be double, right? Class?
Dako, sir.
What is yang maximum load? And what will happen? Pumuda ko. Take note. Pag mag-splice ka, mag-splice. Okay, I want you to figure out. Splice. So, ang imong directions of force is going here, here. So, shear man siya. Shear, we are considering shear here. We will go back on the question.
Mo to siyang 30 na guys.
So, ha?
Mo to siyang 330 na guys ganiya.
Mao?
Mo
No, our consideration. So, upper weld only. So, Sara, 3 times 2. Okay? So, we will compare. So, kay shearman ni siya, both will have an effect. Right? Shearman, ang movement sa force niya, pana. So, unsa may effect sa weld? So, ang effect sa weld, kani siya, mubira ka sa force due to shear. So, na-effect ang both. Unya, kung i-consider nimo ang duha, mas dako jud ang force due to shearing. Duha may nakakonect. And what would be the safest value? Kung mag-analyze ta. Design niya, design.
Kana dawing usa, sir.
Ang gamay.
Anong gamay man? Safe na naman gamay. What? Ha?
Gamay nga P, sir.
Oh, do you think
Value.
it's the gamay nga pin?
Usa ra i-consider, sir.
No, we're talking about the safest value. The bigger value or the smallest value?
Less value, sir.
Ha? Smallest?
Value, sir.
Why do you think nga smallest value is the safest value? Smallest value is the economical value. Gamitan nimo atong dako nga value nga makalculate nimo. Ang madako sa times 2 nimo.
Silbi mo naman ay limit niya, sir. Like,
Ah?
gamay ang iyang value. Limit niya, sir, ba? Limit. If mo exceed siya nga value, sir, which is mo bigay ang imuhang kuan building.
Mao'y limit sa mao'y limit nga makaya niya.
Oh.
Okay. So, mao'y limit nga makaya niya. Og butangan nimo katong ko kayo nga load, what will happen? So, muna kinahanglan kang mo ang safest value is 428.67. Gamay. Okay? 165 times 2, 598. So the smallest value will prevail. Okay. So analysis ani class ha, smallest value will prevail. So gamay ang imong gamiton nga load. Onya based sa common pud ning kuan 10.5. The one that matters only here is the usage of kaning paggamit sa length. Kung mogamit kag duha ka length, it can either be ay shear man naman siya effect both. The other one, they are connected. Ngano mo gamit raman tag upper weld only? Huh?
Maybe say, sir, kay same man sila length, sir. Same pod ang ilang capacity both. Welding. So, pwede ra i-consider nimo tong usa for its safe value.
Ngano dili man nimo i-add?
If i-add nimo, sir, like you're considering duha na mo resist niya, sir. Pero ang safe value jud, sir, kay usa ra jay consider mo usa ra mo resist, sir, kay if in case kuan tong usa guba tong usa katong usa may murag
So, kung mag-analyze ka kanang actual gyud nga analyze, wala ra tay gikuan-kuan na both of the wheels are really contributing factors sa shear. In contact man to sila tanan. So, kung pag-solve nimo gani, pag-analyze nimo maximum load, of course, katong duha ka wheel gyud na to'y contributing factor sa pag-calculate nimo sa imong maximum load. Maximum load nga makaya ato. Pero kung, okay, pag-analyze nimo, ato imong analysis nga, og katong duha, nagod siya contributing factor. Na siya contributing factor nga makakuha ka sa maximum load. How much more kung mag-analyze na kag usa ra imong gi-analyze, ha? The safer it is, right? I-add pa rin mong usa. So muna siya yung mga the safest value actually, pag-analyze nimo katurang usa nga 350 ra ang gitas-on, mura imong gi-analyze, 350 ra ang length weld nimo imong gi-analyze. So muna siya equivalent maximum load nga makaya. Least value. Kung mudako man siya kung duha imong gi-analyze, mas mudako ang load nga imong kinahanglan, usa siya mo fail. Right? Class?
Yes, sir. Sir, pwede mo na, sir.
Okay.
What if kanang laylay slag length, sir? Like, ang usa ka weld, ang iyang length is 350, yung usa is 250 lang. So, you would consider is katorang smallest value of its length ka for its
Dili,
maximum
sulbo
load.
nimo nagtinagsa. Sulbo nimo nagtinagsa. Kaya naman kay total length ana L1 L2 plus L1 L2 mo itong nakakay total length, mag-matter nga na to yung formula ta nga mahimong L1 plus L2. Mag-calculate na kana with respect to, ay na to example number 2, with respect to the material, shear on welds or shear on material. I-compare nimo na, whatever would be the bigger value, mo na imuhang gamiton. Di ka pili na ka sa smallest value.
Okay, sir. Thank you, sir.
Mao to siya ka sa kabantay mo katong natay figure nga kuan. Magamater ka nang kondisyon nga asa ba to nga figure? Okay. Tinagsaon na nimo siya solve class with respect to laylay man ang imong consideration na first analysis, mo analyze ka based on shear on welds. Shear welds ka. Pag humani mo analyze po ka na kay makuha nga tong values. Mo analyze po ka using the base material. Kay laylay man tong base material kakuha man po ka ultimate strength, nominal strength, Fy, Fu. So isolve to nimo, compare nimo. Pag solve nimo makakuha kag mga values and then you're going to conclude. Kini mas in terms of length, kung in terms of length, bigger value. Bigger value ang imong gamiton. Anyway, asa man to? Nang siya, if you remember, katong natay part nga discussion kini siya class. So, different man nga length sa weld niya. L1 ay L2, L3, laylay siya gitason ba in any orientations. Motong natay mga formula nga analysis ana. P1, P2, L total L1, L1, L2 plus L3. Anyway, okay. We'll have the example number 2. Any other question, class? Class. Class, any other question before we proceed to example number 2? Wala. Class, can you hear me?
Okay na, sir.
Yes, sir.
Okay na, sir.
Okay. Okay, this is design. So, ina design. Puol po kayo mag-solve, no? Dahil butong mag-solve ka nga procedural way. Kani, analyze ka mo, dagdo magas code, masikag basa-basa code. Okay. So, we have example number 2. Nakakunoy double angle truss. Double angle truss, kuno siya class, members shown below consist of 2 angles. Duha ka angle nga 125 mm by 88 mm by 10 mm thick. So, muna makita ninyo, this is the angle. Duha siya angle. I-connect na siya sa here is side welded to a gusset plate. So, muna, gusset plate nasto nga imong gusset plate. So, duha ka buok nga double angle truss. Makita nimo, this actually L direkta man na siya. Makita nimo. And then 88 na siya. Napo check corresponding distance to the neutral axis. Okay? So, here, this is the figure actually, kung makita nimo, kung sa atubang ka, ang imong L angle, mo ni L angle, murag double sa taas. Inyo makita kung agi mo tag drawing class, no? So, kani siya katong murag ga-L na ni siya, L angle, kapaana na ni siya. So, gi-welding sa ubos, mas gamay. Ni-weld, pagka diri fili weld gyapon, L1 mo mas taas. So, kanay sa taas, taas imong welding, taas mubo imong welding sa at the bottom portion. So, this is the plate, which is on the center of it. And on the back of this, na po kay the same thing that what is happening on the back. Weld po ka L1 sa rod, niya na po kay L2. Okay. So, the member is to get total tensile force of total tensile force of 848 kilonewton. Using 6 mm Philly weld. Again, ang leg niya. Hindi na problema. With E60 electrode. So, magamit na itong table ka na may E60 electrode. We can get the value of Fu. We made a nominal tensile strength. Determine the length of each Philly weld. Karon, How you calculate, determine the length of each Philly weld. Okay? Required for balance condition. So, balance ang condition. What does it mean, balance condition? All steel are 836 with FY 250. When you say balance ang condition, ano man ang balance and condition? Meaning, ang L1 niya times ang iyang corresponding arm going to the neutral axis, which is 40, is equals to L2, length of L2 times corresponding distance, neutral axis 85. Muna na siya condition mo. Based on that condition, how am I going to solve the length of weld, L1 and L2? L1 times 40 is equals to L2 times 85. So, naka-equation, but you cannot solve. It's only an equation in terms of L1 to L2. So, what other things, other formulas you can use para ma-solve all L1, L2? What are the relationship? The total length of weld, kapalo man ka, the total length of weld is equals to L1 plus L2. So, diha na po ka. Mo-solve ka. Gamito ni mo nga equation. How you are going to solve? Ang imong problema na po, how am I going to solve the total length of weld? So, muna na, ang imong i-apply tanan nga kondisyon. First condition, considered shear on welds, then shear on the base metal. Ang mga base metal properties na 86. Compare nimo to. This is what I'm telling. Nga ingon nga problem, you can determine also two lengths actually. Two lengths, but you need to compare based on the shear of the welds and the result of the other one based on the base metal. Base metal nimo nga naa po kay certain properties of the steel, which is A36 nga na kay FY nga 250 MPa. Okay, you na kay 4.4 of FY man. So you can still solve the length actually. So ingon na class, ang imo is to determine first how am I going to solve. Una kato nga kondisyon. Okay? Una is balance condition. Balance condition, L1 times corresponding length to the neutral axis times 40 is equals to L2 times iya pong length going to the neutral axis. Ana kay relation magyapon ka solve sa L1, L2. L1 equals to the matter of equals to the variable of L2. So you need another equation. Magay formula nga ang total length of weld is equals to L1 plus L2. Ang imong problema na pod is to solve the total length. And total length, ma-solve nimo in two ways. Duha man nimo ma-solve based on the parameters of the problem. Shear stress base sa weld nimo o through the shearing stress using the steel, the base steel actually, which is A36. Okay, so let's solve. For balance condition, na kay equation nga makuha ang L1 times Y1 is equals L2 Y2. So, unya na po kay formula to solve. Kinahanglan makagduha ka equations ani to solve the problem. So, kinahanglan kag ang total length relationship L1 plus L2. And your problem now is to solve for L. Once you got the value of L, so these two equations already, you can pwede nimo i-substitute na nimo ang other value. You can solve for L1 and L2. And it solves your problem. Okay. So from table 3.1. Ano magamit lang table 3.1 class? For electrode nga E60 electrode, ang equivalent nimo nga ultimate nominal tensile strength FU is 425. Okay. Mo adto ta table pakita tong table 3.1. Okay, table 3.1. So kung na-day ko ang class NSCP and you have the copy of the table 3.1 from okay. Okay, A60 electrode. Pila man ang iyang minimum tensile strength FU? 425, right? Kita class?
Yes, sir.
Okay. So, okay, nakita na to stable. Let's go back on that problem. And then, sana to? Wait na. Okay. And then let's have, so from table 3.2, allowable shear on the effective area of weld. So atong unang analysis para makasolve sa total length is using the allowable shear on effective area of weld. So the next part is we will solve using the base metal. Atong properties niya. So let's have allowable shear on effective area of weld. We know that allowable shear is equals to 0.3 of FU. So 0.3 of FU, 0.3 times how FU is for E60 electrodes, table 3.1. You have 424. And how much that one class? 0.3 times 424. 425 actually. Pila class?
127.5.
Okay, 127.5. So, nay FD. Saan pag-solve man nato ana ron? Naman tayo formula nga, given man ang maximum tensile load, P is equals to 0.707 shear stress, allowable shear stress. P is equals to allowable shear stress times area shear stress. So from table 3.2, allowable shear on base metal, napo tayo allowable shear base metal. Okay. So magamit nato ni after. So let's solve first. Allowable sa 3.2 shear on base metal 0.4 of Fy. Fy is given us for A36. Okay, given siya dito nga 50 on the problem. Okay? So ano naman ni-mention table 3.2 allowable shear on base metal. Dito ni gikuha ni nga formula 0.4 of Fy. So let's atong adtuon nga table class. Para sabta ninyo. 3.2. So let's go. Adto mo 3.2 class. Kanya okay, this one. Adto mo 3.2 of your notes, or you can go to the structure of the NSCP. Makita niyo shear on effective area 0.3 of the nominal tensile strength. Sakto ba? Nominal tensile strength of weld metal except shear stress on base metal mo to ni gamit kag 0.4 tas the yield stress. Base metal man tong analysis. So tong 0.4 times Fy. Klaro class? Ha? Class? Okay?
Okay, sir.
Okay, sir.
Okay. So inani makabungog ning kuan design daghang kang tanaw-tanawon eh. Okay. So let's have sana to. Wala na po. Okay. So this one. Okay, what will happen here is allowable shear. So allowable shear on this base metal is 0.4 of Fy. Base metal man imong analyze. Katupong kuan, allowable shear on effective area of weld, napo dito naka-mention nga 0.3 of the nominal tensile strength, Fu. Okay, kung base metal ang imong analysis, ang imong gi-analyze na pod is equals to 0.4 Fy or the ultimate strength Fy of the base metal, which is A36. So 0.4 of 250 given man siya, is it 100? Yes. Kaupato ni mong divide mo 1/4 ang 250 0.4 times 250 is 100. Class, pabuto na sipiat dere.
Yes,
Class?
sir.
Okay.
Yes, sir.
So naa na ta diya. After that, we will consider one member only. So usa ka member ang imong i-consider. So since ang imong total atong balikan sa atong problem. Asa naman to? Wala pa nung ko. Okay, asa na to? Okay. So you consider one member. Kay bali-bali man ni siya. Na kay gazette plate on the center. Connected siya bali-bali man yung L angle nimo. So we will consider this one. Kaning usa. So nya ang kani kay total P man eh. If you analyze total connected on both. Connected ba na siya both? Duha ka angle. Duha ka L angle. I-divide mo ng P, which is given there nga total man na siya, total tensile force is 848. If you are going to analyze the half portion of it, you need to divide P into 2. Okay. So, di na tayo maglibog na. So, i-divide na to considering one member only. So, 848 divided by 2, that is already naka P. Ano kailangan mag-P? Take note class nga our concern here, ang kinahanglan natong makalculate is the length. Length ang target here. Mo to pagsugod na to, kinahanglan nato total length so that we can have the relationship natong two equations. We can solve L1 and L2. So length of weld in one side, okay, in one side nato i-calculate. Forget about the back side, which is typical. So L1 plus L2, naka-relationship na total length of weld. If you on the figure, makita niyo mas taas ang usa, L1 niya, L2 mas gabi, mas mubo. Okay, so total length of weld is L1 plus L2. Okay, based on weld metal shear, ang P nimo is equal to shear stress. This is the whole shear stress times point, okay, 707 thickness times length. Okay? So, substitute lang yung values class. 424 is equals to 127. 27. Huh? 127, where did we calculate this one? Based on shear. Weld. Atong balikan. Kasi galibog na mo. Weld metal shear. We calculated this one. Here, allowable shear on effective area of weld. Motong nakakay 127.5. So, based on weld metal shear, nakakay allowable shearing stress no 127.5. Based on the weld na siya. Times, okay, 0.707 times 6. 6 given ang thickness of the leg, weld. Let's go on the is it given? Given class? Is it given? Ano naman ron? 6 mm Philly weld. Okay? Class? Ang leg niya weld. Class? Asa na mo?
Okay,
Ano
sir.
dia?
Okay, sir.
Okay ra? Okay. Okay, so let's continue. Times L. So if you evaluate this equation, you can solve the length, the total length of weld based on metal shear. So nakakay 7. If you calculate based on the base metal, which is 0.4 of Fy, gamitan po to. P is equals to nga ang area, shear area nimo. Ano sa may shear area nimo kung metal, base metal ra? Ano sa may shear area nimo? Ang imo rang thickness of the weld ra. Or the web thickness. Leg thickness actually. Meaning the leg of the weld. Pila man to? Okay. Which is equals to 6 times the length ra. Length directly. Length. So, maura na siya ang imong shear based on base metal. Munang nakay 6L. Okay. This is the contact area between the weld and the metal. If you go back, pila man ito'y contact niya? Ang contact area niya is equals to length niya times kung pila ang iyahang thickness. of the leg. Okay. So P is equals to FBAV. So base metal shear niya, you will get also the value of substitute. You will get the value of L, which is 706 mm. So yeah, pa-conclude ka what you are going to use. What would be the length value? Na makadua. Ano sa may length ngayon mong gamiton? Dako, gamay. Class. Ano sa mong gamiton? Dako, gamay. Total length of wheel. Anyone? Basi Juan. Cereales, La Cruz. May naghanang absent. Dicen. Ibura. Asa na mga tawanan eh?
Dako, sir.
Ganahan juga dako. Dako man. Okay, tell me nganong dako. Tell me something. You need to use the bigger value of the total length of wheel. Why? Nganong dili pareha og principle sa load nga nganong mo gamit man tagamay. Nyag malint dako. Tell me. Ambot, sir. Basta kay dako. Ang ganahan, sir. Tell me.
For safety, sir.
Safety process. Okay, overall, in over conclusion, safety purposes. Okay, I agree. But what's the main? So,
Wag dako, sir. Dako, length pod nga ma-scatter tong stress ba? Force.
actually, okay na nang minung kang for safety purpose. That's too general. That's the main thing. Safety purposes. But kung i-analyze, if you are going to use the smaller value of L, ang imong allowable nga shearing stress calculated will be, allowable man to. Kung gamiton ko nun mo 706 nga length, nya imong i-substitute na dire, you will not get 127.5. Makuha ba nimo ning 127.5? Pili mong makuha kung imo i-substitute nga L, mas gamay. Ha? Pila, let's try to evaluate. Okay, your L, okay, let's help. Pila to L, 706. Let's solve for the max, shearing stress. Allowable. Allowable, ha? Ano naman ay allowed niya? 127. If we try to calculate 706, okay, imong length times 0.707. Okay.
Or
Pila?
141.5.
So it will exceed on your allowable, which is not acceptable, right? Sakto ba? 2.4 akong gi-calculate sa okay. So 0.707 times 6 times 706, you will get, okay, 424 divide ons 141. So allowable man na, allowable shearing stress man na, allowable meaning dili ka mo exceed. Ang 141 naman, so that's the reason, dili ka for safety purposes. When you use the smaller value, the other criterion with respect to weld metal shear will exceed allowable shearing stress. Instead of 127, you will get 141.58. Kuha na to, class? Ha?
Yes, sir.
Yes, sir.
Okay. So, kuha na to. Ruben. Yeah. Okay. So that's okay. That's the reason why we use the bigger value, the calculated total length of wheel. Okay. So, okay. So you will get, so therefore, you conclude and use the 10th, that is the bigger value, 784 millimeter. So, for balance condition, na naman kay, balik na ka atong imong formula. Nga balance condition, L1Y is equals to L2Y2. So, L1, ang Y1 corresponding distance, balance gani, kaduong gunas neutral axis, asa no neutral axis? To the two sections. So, L1 times 40 equals to L2 times 85. So, you have a relationship L1 internal L2. So, L1 is equals to 2.125 L2. And the other relationship, L is equals to L1 plus L2. You calculated already L. Total length weld is 784. Substitute this. Then substitute L1 in terms of L2. You will solve L2 of 250.88. Is it correct? Please calculate, class. L2. Okay. 3.125.
Sir.
Okay, 784. Okay, 784 divide 3.1. Correct? Right? 50.88.
Yes,
so
Yes,
nakakuha na kag L2, substitute the values. These are the value that you have compared for L1. So 2.125 times 250.8, you will get L1. Solve na imong problema. Okay, class? Okay, class. So that ends our discussion for today. Any question so far, class? So expect nga tagan ta mo og assignment karon, kanya magdugang putag na po additional problems to solve on Tuesday. So because I purposely do this, even I already announced some Tuesday because one of the section delayed kay sila. Only the section B, section A actually. So I need to balance. Muna example lang tagdugang Tuesday, and by Thursday you will be having your exam. Okay?
Okay, sir.
So
Yes, sir.
hatagan ta mo assignment pod class to solve, practice po mo solve. Okay, practice. So I will discuss Tuesday katong nanay eccentricity. Okay. So something magamit po nato tong uban nga ipang discuss dito hanggaayong mga unsan lagi pang istorya. Okay, at least makita po ninyo. Okay, and then please solve your assignment or practice solving. And then you don't have any question for today's discussion. We will end the discussion and see you on Tuesday class. Any question, class?
Sir.
Huh? Oh, one side na nga. For one side. So equal na siya, class. Ang effect po sa PCAS maupod. Kung pila value diha sa PCAS pod maupod. Okay. Any more question, class? If questions, we will end up the discussion. Okay.
None, sir.
Answer.
None. Okay, so we will end up the discussion. Thank you so much, class, and see you on Tuesday. Bye-bye.
Thank you, sir.
Thank
Thank
you,
you.
sir. Bye, sir.
Bye.
Sir.
Sir.